So in this case, we are going to calculate the field of line charge or charge potential relation for two conductor line. So in this case, in previous lecture, we have derived the equation for electric potential, electric field intensity or electric field potential at that particular point, which is equal to q upon 2 pi epsilon 0 epsilon r into 1 upon that distance. So in this case, these are the two parallel conductor. Each of them are having radius rho. इथे पाहू शकता प्रिव्हियस केसमध्ये आर आपण कन्सिडर केलेली रेडियस हिअर द डिफरन्स इज ओनली व्हॉट द रेडियस इन दिस केस इज रो नाउ it is separated by a center to center distance which is equal to small 2d okay 2d हे त्या दोघांमधलं सेपरेशन डिस्टन्स आहे and both of these conductor are carrying opposite charge of opposite polarity. Let us say suppose this conductor is carrying charge plus q and this conductor is carrying charge minus q. As I told you, both of them are having same length of 1 meter. Now what we will do, we will consider let us suppose there is a point P at a distance x from one of the conductor. So this distance will be, it will be 2d minus x. Okay, see आपण ज्यावेळेस इलेक्ट्रोस्टॅटिक फील्ड कॅल्क्युलेट करतो विच इज इक्वल टू 1 अपॉन q upon 2 pi epsilon 0 epsilon r into at this particular point P, the electrostatic field it is due to charge on this conductor and charge on this conductor. So in this case there will be two fields, one is due to positive charge, one is due to negative charge. So what is the distance of this point P from positive charge conductor or center of this conductor? It is x. And what is the distance of this point P from this conductor? It is 2d minus x. So if I am going to calculate the electrostatic field, you know that it will be q upon 2 pi epsilon 0 epsilon r 1 upon, let us say r is nothing but the distance of that point from respective charge for which we have to calculate the field. Okay, so in this case the field due to positive charge, let us say suppose E, it will be q upon 2 pi epsilon 0 epsilon r into 1 upon x. Let us say suppose E1, and second it will be E2, it will be q upon 2 pi epsilon 0 epsilon r into 1 upon 2d minus x. Okay, and the total field is nothing but the addition of these two. Okay, so let us start the derivation. So what we are going to do, we are going to place a unit positive charge at point P at a distance x from the center of the one of the conductor. Let us say suppose that conductor is this one. So we have placed a unit positive charge at point P and we have to find out the force acting on this particular point P. So that force will be, it is denoted by EP, it will be q upon 2 pi epsilon 0 epsilon r into 1 upon x plus 1 upon 2d minus x, and it will be in Newton per coulomb or volts per meter. Now this is nothing but the electrostatic force at this particular point, but next we have to calculate the potential difference, and that potential difference it will be denoted by phi. Let us say there will be a potential difference present between these two conductor. So it will be present in between which distance, या पॉइंटचं डिस्टन्स काय इथपासूनचं, it is rho. So that potential difference it will be present in between rho to 2d minus rho. See, इथपासून या पॉइंटचं डिस्टन्स काय, it is 2d minus rho. So the potential difference I hope that diagram is also visible to you. So the potential difference between the conductor. And as I told you, it is denoted by phi. It is equal to, see, you know that it is E into dx. So if I'm going to place the values, it is q upon 2 pi epsilon 0 epsilon r integration from rho to 2d minus rho 1 upon x plus 1 upon 2d minus x into dx. So this is nothing but the potential difference. Let us solve this equation further. Okay, so it will be q upon 2 pi epsilon 0 epsilon r. I will take the integration. It will be ln of x with the limit rho to 2d minus rho minus ln of 2d minus x in between limit rho to 2d minus rho. हे समजतंय का मी काय केलं? See, potential difference, that potential will exist in between that two conductor, and that will be from rho to 2d minus rho. So I have taken the integration of EP from within the limit rho to 2d minus rho. I will get this. So let us solve again for the q upon 2 pi epsilon 0 epsilon r. If I am going to place the limit in this, so it is ln of 2d minus rho minus ln of rho. Okay, so what I will do, I will place it in bracket minus, here instead of x you have to place 2d minus rho. So what will be happen, ln of 2d minus 2d plus rho. हे कसं आलं समजलं का? x ची व्हॅल्यू काय, 2d मायनस रो. सो या मायनस साईनने जर मी याला मल्टिप्लाय केलं मायनस 2d प्लस रो, राईट, and minus ln of 2d minus rho. I hope you understood this. So let us open the bracket. It will be q upon 2 pi epsilon 0 epsilon r ln of 2d minus rho minus ln of rho. I will multiply with minus sign inside the bracket. It will be minus ln of 2d will get cancelled. It will be minus rho minus minus will get plus ln of, see, this minus and this minus will get, it will get plus 2d minus rho. So see, these terms are same, these are also same terms. So finally you will get q upon 2 pi epsilon 0 epsilon r to ln of 2d minus rho minus 2 ln of rho. This can also be written as, if I take this 2 common, this 2 will get cancelled from that, means it will be 2 q upon 2 pi epsilon 0 epsilon r, and this also written as 2d minus rho upon rho. This 2 will get cancelled, and finally the equation will be phi is equal to q upon 2 pi epsilon 0 epsilon r ln of 2d minus rho divided by rho. Okay, so what will happen? See, in this particular diagram, this rho is nothing but the radius of this conductor, okay, and 2d is nothing but the distance of separation of these two conductor. And I think you might be aware about this key. जर दोन आपण कंडक्टर बघितले तर दोघांमधलं जे डिस्टन्स ऑफ सेपरेशन असतं ते खूप जास्त असतं. ओके, त्या कम्पॅरेटिव्हली जर आपण रोची व्हॅल्यू म्हणजे त्याचा कंडक्टरचा रेडियस आणि त्या डिस्टन्स जर कम्पेअर केलं तर रोची व्हॅल्यू किंवा रेडियस खूप कमी असणार आहे. ओके, सो इन्स्टेड ऑफ रायटिंग 2d मायनस रो मीन्स 2d मायनस रो हा नियरली इक्वल टू 2d असणार आहे. सो इफ वी कन्सिडर if this 2d is very greater than rho, so that equation of potential difference phi will be q upon pi epsilon 0 epsilon r ln of 2d upon rho. See, as 2d is very greater than rho, this 2d minus rho, it is nearly equal to 2d. So what is potential difference? It will be phi is equal to q upon pi epsilon 0 epsilon r ln of 2d upon rho. So this is about potential difference. Now we know that what is the relation between potential म्हणजे voltage, capacitance आणि charge यांच्यामधलं रिलेशन काय आहे? Q, you know that Q is equal to C into V. Okay, सगळ्यांना माहिती आहे की what is Q? Q is equal to C into V. So from this equation what is C? C is equal to Q upon V. जर V ची इक्वेशन म्हणजे मला जर कॅपॅसिटन्सचं इक्वेशन फाइंड आउट करायचं असेल तर आय कॅन यूज दिस फॉर्म्युला. सो हेन्स the capacitance of a conductor with 1 meter length it will be, as you know, C is equal to Q upon V. So let us place value is Q divided by Q upon pi epsilon 0 epsilon r ln of 2d by rho. So the capacitance for this two conductor line, it will be pi epsilon 0 epsilon r divided by ln of 2d upon rho. So see, in this particular derivation we have derived the equation for capacitance for two conductor line. Now what further we are going to do, आता या केसमध्ये काय केलेलं आपण, we have calculated the electrostatic field at this particular point P आणि potential difference या P पॉइंटला कॅल्क्युलेट केला, बरोबर आहे. आता हा P पॉइंट जर मी इथे शिफ्ट केला या कंडक्टरवरच तर काय होईल, समजून घ्या. हा P जर मी इथे शिफ्ट केला, आता इथे होता P पॉइंट एक्स डिस्टन्सवर होता. आता एक्स डिस्टन्सवर असल्यामुळे काय आलं, EP इज इक्वल टू क्यू अपॉन 2 पाय एप्सिलॉन 0 एप्सिलॉन आर 1 अपॉन एक्स. एक्स काय होतं, या Pचं पॉझिटिव्ह चार्ज कंडक्टर जो होता त्याच्यापासूनचं डिस्टन्स. 2d मायनस एक्स काय होतं, निगेटिव्ह चार्ज कंडक्टरपासूनचा डिस्टन्स. पण हाच पॉईंट जर मी इथे शिफ्ट केला या पॉईंटला तर पॉझिटिव्ह चार्ज कंडक्टरपासूनचं डिस्टन्स काय घेतलं, यस प्लीज. हे कंडक्टर एअरमध्ये आहेत, हा पॉईंट मी कुठेतरी इन बिटवीन दिस कंडक्टर कुठलाही एक्स डिस्टन्सवर कन्सिडर केला. पण जर मला हे जे व्होल्टेज ग्रॅडियंट आहे हे मला एक्झॅक्टली त्या कंडक्टरच्या सरफेसवरच कॅल्क्युलेट करायचे असतील तर त्या केसमध्ये सी हिअर सपोज दॅट पॉईंट इज पॉईंट पी, इट इज ऑन दी कंडक्टर. त्या पीचं डिस्टन्स फ्रॉम दिस सेंटर इट विल बी रो. ओके, आणि या कंडक्टरच्या सेंटरपासूनचं डिस्टन्स काय असेल, एनीवन प्लीज, whether it will remain 2d minus rho. Very nice. So EP will be q upon 2 pi epsilon 0 epsilon r 1 upon rho plus 2d minus rho. So what further we are going to do, we are just going to calculate on the surface of any one of the conductor. Okay, so on the surface of any one of the conductor, the voltage gradient that E is equal to q upon 2 pi epsilon 0 epsilon r. It will be 1 upon rho plus 1 upon 2d minus rho. Okay, so I will do some rearrangement. Right now I have written equation E is equal to, I will write it down again, q upon 2 pi epsilon 0 epsilon r 1 upon rho plus 1 upon 2d minus rho. So what I will do, I will just multiply and divide to this equation by ln of 2d by rho. म्हणजे या इक्वेशनला जर मी ln of 2d by rho divided by ln of 2d by rho याने जर मल्टिप्लाय and डिवाइड केलं तर काय फरक पडणार आहे का? No, means it is not going to make any effect. So let us do rearrangement. This equation can also be written as q upon 2 pi epsilon 0 epsilon r into ln of 2d by rho into 1 upon rho plus 1 upon 2d minus rho into 1 upon ln of 2d upon rho. Okay, so if I just neglect this 2, q upon pi epsilon 0 epsilon r ln of 2d upon rho, हे काय असतं? हे कशाचं इक्वेशन सांगताल का मला? सी हा 2 नसेल, सपोज this q upon pi epsilon 0 epsilon r ln of 2d upon rho, this equation is of, check करा. Yes please. See, just 2 minutes before we have derived the equation. See here, this v is equal to q upon pi epsilon 0 epsilon r ln of 2d upon rho. बरोबर आहे. तर इथे q upon pi epsilon 0 epsilon r ln of 2d upon rho, this can also be written as v. Okay, so this above equation it will be v divided by 2. ही टर्म इथे लिहितो, it will be 2 ln of 2d upon rho, what else, into 1 upon rho minus 1 upon, sorry, plus 1 upon 2d minus rho. So this is nothing but voltage gradient on that conductor. Now आता या केसमध्ये आपण काय करूयात, सपोज मी काय केलं, हे व्होल्टेज ग्रेडियंट ऑन दॅट कंडक्टर, जर या केसमध्ये मी सेकंड जो कंडक्टर आहे, आता आपण असं म्हणलेलं की हा एक कंडक्टर आहे, हा दुसरा कंडक्टर आहे, ठीक आहे. सो इफ आय एम गोइंग टू निग्लेक्ट द इफेक्ट ऑफ दिस चार्ज ड्यू टू कंडक्टर सेकंड, आपण जी डायग्राम पाहिलेली समजून घ्या. सी, in this case, let us say suppose this conductor is not present. So whatever will be the electrostatic field present over here, it will be due to this conductor only. मग त्या केसमध्ये मला 2d minus rho कन्सिडर करावं लागेल का? नाही. So in this equation, if I am going to neglect the effect of charge due to second conductor, the whatever will be the electrostatic field present, it will be due to first conductor only. So let so E will be, see, heat term ka will, it will get cancelled out. So what else there? E is equal to V upon 2 rho ln of 2d divided by rho. हे असं काय केलं आपण, कारण की ते जे दोन कंडक्टर आपण कन्सिडर केलेले, it is having charges plus q, it is having charges minus q. So as I told you, these are this distance 2d. या दोन्ही जे कंडक्टर आहेत हे खूप म्हणजे दुसरा कंडक्टर हा फर्स्ट कंडक्टर पासून खूप लांब आहे, त्याचा डिस्टन्स खूप जास्त आहे. त्यामुळे याचा जे चार्ज आहे त्या चार्जचा जर सपोज या पॉईंटवर इफेक्टच पडत नसेल तर याचे फील्ड इथे कन्सिडर होणार आहे का? नाही. सो इन दॅट केस इफ वी आर गोइंग टू निग्लेक्ट द इफेक्ट ऑफ charge on second conductor, the electrostatic field at this particular point or voltage gradient at this particular point, it will be E is equal to V upon 2 rho ln of 2d upon rho.